Hello everyone, today we are going to start reviewing similar triangles, what we had learned right before spring break and tested right before spring break. So if you missed that test, make sure that you're doing these assignments this week and next week and the test that'll be posted so that you can make up those points that you're missing from before spring break. Alright, so real quick, we're going to have a reminder about similar figures. Now remember, similar means that these shapes are the same shape. Similar means we have the same shape, but there is something that's different. What's the thing that's different? Yeah, they're not necessarily the same size. So they could be the same size, but that would mean they are congruent in addition to being similar. Similar means they've got the same shape, but they're not necessarily the same size. Alright, and we know that similar figures are going to have congruent angles. Alright, because if your angles are not congruent, if your angles are not the same, then that means you've got a different shape. They both might still be triangles, but they're triangles that are shaped differently, alright? So your angles must be congruent in order to have similar figures. But because our sizes are not necessarily the same, that means you need to have proportional sides, which is what we're going to be focusing on today. Alright, proportional means you have one fraction that is equal to another fraction. Alright, so with that being said, we're going to take a look at some of these examples here, and then you guys should be good to go. Now, all of these are basically helping us set up proportions, setting up fractions that are equal to each other because of a specific relationship. For example, in the angle bisector proportional side theorem, an angle bisector cuts an angle in half. So we've got congruent angles, and that means we are going to have proportional sides in those triangles as well. Those triangles may not be similar, but because the angles are congruent, we can show that the sides are then proportional. Alright, so in example 1 and 2, it says that CD is bisecting angle C. So what I'm going to do is, here's CD, that's the bisector. And we want to solve for AC. So we're given 9, and then here's AC. There's one triangle. This is our AC. Yeah, I'm not going to put anything there right now. And then on the other side of this angle bisector, we have an 11 and then a 22. So to set this up, there's multiple ways you can set it up. I'm going to show you both because either way you're going to get the same answer. You could set it up as the orange triangle as one fraction and the green triangle as another fraction, making sure that the things that are touching or adjacent next to each other are lined up in your proportion, or lined up in your fraction. So since 9's on top, I'll go ahead and put 9 over AC, so 9 and AC, and then I'll put the fraction symbol in between, like that. Just see how that's kind of acting as my fraction, and then it's equal to what's touching or next to the 9 is this 11. 11 is also on top, so this is 11 over 22. And then how do you solve a proportion? You cross multiply and solve for your missing piece. If we wanted to set it up differently, you could also set it up as 9 over 11. Alright, 9 and 11 are adjacent to each other, so you can set it up as a proportion 9 over 11, and that means your other proportion would have to be what matches with the 9? The other orange, AC. So AC would have to go on top. And then your 22 would go on bottom. There's lots of different ways that you could set this up, but your proportion, I like to color code, your proportion should never look like a checkerboard. Your oranges should never be diagonal from each other. Alright, everything is always going to line up. Alright, so when we cross multiply, I'll do both of these to show that we're going to get the same answer either way. Alright, 9 times 22 is 198, and 11 times AC is 11 AC equals 198. And when we divide by 11, we get AC is equal to 18. Alright, checking the other side. When we cross multiply, look, we end up multiplying the same things. We get 11 AC and then 9 times 22, which is 198. So either way, we're gonna get the same answer. Alright, so if it helps, color code your triangle, color code your proportions to make sure you're setting it up correctly. Alright, we'll do example 2. BD bisects angle B, so I'm going to kind of highlight that in my dark. That's going to help me set up my proportion. And now I'm going to color code. One of my triangles, I've got this 6 and this 14. And then in the other one, I've got DC and 16. So I'm only missing one side, DC, right here. So I'm going to go ahead and set up my proportion. You can set it up whatever way you want to. I'll go ahead and do 14 over 6. And then my other side is going to be what matches up with the 14. What side is touching the 14? This 16, alright, is adjacent. It's touching the 14. It's on the other side. So 16 matches with the 14. And then DC is on the other side of that 6. Alright, so now we're going to cross multiply, and we're going to get 14 DC equals 6 times 16 should be 96. So then we're going to divide by 14. Whoop. And DC, 96 divided by 14. Ooh, we are going to get a decimal, and that's okay, so we're going to have to approximate. So then we'll put 6.9. 6.9. Now, real quickly, make sure... Oh, that whole time you couldn't see. My bad. Make sure that you read the directions and know what it's asking for, alright? Because our directions here tell us that they want us to solve for AC, alright? Where is AC? AC is this whole thing, alright? So, if we found DC, and we know that DC is 6.9, AC is going to be 6 plus 6.9. So that means AC, now we had to approximate, so I'll put approximately. 6 plus 6.9 is going to be approximately 12.9. Alright? And there's example 2. Okay? So you guys are also going to see some word problems where you're going to need to set up proportions. So here's an example. We've got a map here, and they give us all the numbers we need over here on the side. Alright, see if I can focus this a little better. Perfect. Alright, so the distance from the ATM to the coffee shop is 300 feet. Oh, I forgot this part up here. I'll go ahead and read it. North Craig Street bisects the angle formed between Belfield Avenue and Ellsworth Avenue. So North Craig Street is our bisector. Alright? The distance from the ATM to the coffee shop is 300 feet. ATM right here, coffee shop right here, 300. Okay, there's the 300. The distance from the coffee shop to the library is 500 feet. Library, that's the L. So this other side, this is 500. Alright, the distance from your apartment to the library is 1200. So here's your apartment, here's the library. That is 1200. Alright, because we can see right here and right here, this is the same triangle. So that's why I color coded it the same color. What we want to know is what is the distance from your apartment to the ATM. So we want to know this distance right here. Alright, so set up this proportion. I can go ahead and do like question mark over 300. Okay. Sorry, move this so you can see it. Question mark over 300. Just like that. And then on the other side, what would we have on top of our fraction? The 1200 over 500, because 1200 is on the other side adjacent to that angle bisector from the question mark. So 1200 over 500. Then we cross multiply. Crisscross applesauce. Alright, so we have 500 times this question mark equals 300 times 1200. So that should be 36 with 4 zeros. Yeah. Alright, and then we divide by 500. So our question mark is equal to 720. Alright, guess what? This was a word problem, right? So how are we going to answer? With our words. So we would say the distance from the apartment to the ATM is 720 feet. Period. There we go. Alright, we're going to take a look at a couple other proportion theorems, and then you guys will be all set. Okay, so I'm going to flip this to the other side. These other two proportion theorems that we're going to focus on right now are all based off of parallel lines. Alright, so if we've got triangles that have parallel lines, a triangle inside a triangle, right, because we've got this small triangle here, and then we've got this big triangle, ABC, but we've got bases that are parallel. Or if we've got parallel lines that are cut by transversals, we are still going to see proportional sides. Alright? And again, I'm going to color code, and I really like these because the parallel lines do a lot to help us set up our proportions. Okay? So, in examples 4 and 5, we've got two triangles, this small triangle here, and then this big triangle here, and they've got parallel bases. So, these are our parallel bases, but it's this one in the middle that tells me how to set up my proportion, because it acts as the fraction bar. It acts as the fraction symbol. So I can set it up like this. My x and 5.7 all come from the same triangle, that small one. And then on the other side, the whole triangle side would be 16.28 plus x, but we're just setting up the proportion of x over 16.28. Alright, because these bases are parallel, we don't have to add anything here. It's just setting up your proportion. Alright, and then cross multiplying to solve for x, like what we're used to. Alright, so I'm going to go ahead and set this up. And again, lots of ways you can set it up. You can set it up as x over 5.7 because they're both orange, and then 16.28 over 7.4. Or I like to set it up using this as my fraction bar. So I'm going to do x over 16.28. And then on the other side, I'm going to have 5.7 over 7.4. Alright, again, cross multiply just like we're used to. And so we're going to get 7.4x equals 92.796. Okay, that's not too long of a decimal, so I'm going to leave it as exact for right now. So 92.796. That's not that long of a decimal, and I want my answer to be as exact as possible. So now I'm going to divide by 7.4, and we get x equals 12.54. Alright? For example 5, it's the same exact idea, it's just we don't see a triangle being formed. But if we were to continue these lines, they would eventually touch and form a triangle, right? So it's the same exact idea, guys, alright? These lines are all parallel to each other, but it's this one in the middle that's gonna show us our fraction bar, how we should set these up as fractions. So this 2x minus 1 and this 35 are both on the top side, and then 3x plus 9 and 77 are both on the bottom side. So when we set this up, the way that I'm going to set it up is exactly the way that I see it. I see 2x minus 1 and 35 on the top. So I'm going to put them both on tops. And then in my denominators, underneath the 2x minus 1 is 3x plus 9. Okay, notice how 2x minus 1 and 77 are completely across from each other in the picture. They are also completely diagonal across from each other in my proportion. Alright, that is always what you want, how you want to set it up. Alright, so when we cross multiply here, we've got a polynomial here. This is more than just one term, so guess what we're going to do? We are going to be distributing. This is how that looks. So we have 77 times 2x minus 1, and then on the other side we have 35 times 3x plus 9. Alright, look what we've got to do here. Distribute. 77 goes to everything in the parentheses that it's touching. So 77 times 2x is 154x. And then 77 times a negative 1 is a negative 77. On the other side, we have 35 times 3x. and 35 times 9. Alright, so there we're going to have 105x plus 315. Okay, and now we move things around to solve for x. So I'm going to go ahead and move the 77, and to move it we need to add it to move to the opposite side. Moving to the opposite side means we do the opposite action. So I'm going to add 77, and I'm only adding it to the 315 because those are the like terms. We can only combine like terms. This should be 392, correct? Yeah. Alright. Then we can move this 105 by subtracting 105x. Alright. And we should get 49x equals 392. And then you guys know what to do from there. We divide by 49, divide by 49, and so we get x equals 8. Now, if we wanted to know what that actual number was, we would substitute 8 in for x to find out what that actual measurement is. So 2 times 8 is 16, minus 1 is 15. So that number would be 15, and then this would be 3 times 8 is 24, plus 9 is 33. Alright? But here, it just said determine the missing value, so we're solving for x. The very last one is a mid-segment. Alright? So, it is still proportional. There's a special relationship here. But we can set it up a little different. So basically there's a shortcut to setting it up so that we don't have to worry about fractions. Alright? The triangle midsegment theorem is telling us that the midsegment of a triangle is half the measure of the third side of the triangle, or half the measure of the base that it is parallel to. Alright? So in other words, I'm going to label this picture so that we can kind of see it. This is our mid-segment, so I'll put mid for mid-segment, and then this is the base that it's parallel to. Alright? And what the mid-segment theorem is telling us is the proportion 1/2 is always going to be equal to our mid over our base, because our mid segment is 1/2 of our base. So mid over base. So it's still a proportion, two fractions equal to each other, but there's a shortcut to setting this up so that you don't have to worry about cross multiplying and that sort of thing. If we were to cross multiply, look at what we would have. 2 times mid, 2 times your mid segment would be equal to 1 times your base. 1 times anything is that thing, right? So 1 times base is just base. Alright? So this is our shortcut. This is our shortcut to the proportion. That's the proportion, and this is after we've cross-multiplied, alright? So, anytime you have a mid-segment, meaning that you've got parallel sides and these non-parallel sides are congruent to each other, because mid means it's cutting something in half, it's in the middle, alright? We can set up this relationship. So, on example 6, if we have 2 times mid equals base, what's our mid segment here? the 3x plus 4. So 2 times 3x plus 4. What should I have there? Parentheses around the 3x plus 4 equals our base of 68. And from there, we're going to distribute and solve for x. Alright, so 6x plus 8 equals 68. Subtract 8 from both sides. So now we have 6x equals 60. Divide by 6. And x equals 10. Alright? In example 7, it's the same idea. Alright? They give us that t is the midpoint of yz, meaning that these are congruent to each other, and u is the midpoint of xy. Alright, so we know this is a mid-segment, and now we can set up our proportion. So 2 times mid equals base. What is our mid-segment? The 6x plus 11. What do we need? Parentheses equals 17x minus 3. So when we distribute, we're going to get 12x plus 22 equals 17x minus 3. Alright, move some things around here. I can subtract 12x from both sides. And so we're going to get 22 equals 17 minus 12 is 5x minus 3. Add 3, add 3. So now we have 25 equals 5x. Divide by 5, so we're going to get x equals 25 divided by 5 is 5. There we go. If we wanted to know the actual measurement of the mid-segment, we would substitute this in. So here our mid-segment would be 6 times 5, which is 30, plus 11, which is 41. If our mid-segment is 41, that means our base is going to be twice the length, alright? So that means our base would be 82. And if you were to plug 5 into there, you should get that number, alright? So there's our review, guys. Go ahead and take a look at the assignment and let me know if you have any questions or need any help. I'll see you next time.